Somewhere in the red centre of Australia, there is a patch of ground where the earth itself still remembers being on fire. 14 craters are gouged into the desert floor here, some small enough to step over, one large enough to swallow a house whole. And for more than 4,000 years, a single detail about this place was passed down with such precision, person to person, voice to voice, that when scientists finally arrived to study it directly, the Aboriginal guide walking with them simply stopped. He pointed toward the craters and refused to take another step. His people, he said, were forbidden from going any closer. Something had come down from the sun and made its home in the earth here. Something that burned. Not a myth about a god. Not a vague warning about bad luck. A specific, physical, repeatable claim about fire, about the sun, about the earth swallowing something whole. On its own, that sounds like folklore, the kind of story that grows taller with every generation that repeats it. The kind you'd expect to be quietly dismissed once real scientists showed up with real instruments. Except researchers today believe it's closer to the opposite of folklore. They believe this account may be one of the most accurate pieces of eyewitness testimony ever preserved by a human culture carried, largely unchanged, across more than 200 generations, describing an event that modern science can now independently date to within a few centuries of accuracy. A strike from space violent enough to light up the horizon, boil the ground, and leave scars still visible from the air 5,000 years later. And here is the part almost nobody outside Central Australia has ever been told. For nearly 50 years, after outsiders finally confirmed what the traditional custodians of this land had always known, that these were not sinkholes or quarries, but the wounds of a meteorite strike, almost nothing was done to protect what remained. Collectors came, visitors came, piece by piece, crate by crate, the physical evidence of what happened here was carried off the site, shipped overseas, sold, and scattered into drawers in museums on the other side of the planet, until some of the rarest geological evidence on the surface of the earth had all but vanished from the very ground where it fell. This is the story of the Henbury craters, a place the oldest culture on this continent warned people to stay away from, long before anyone standing in a laboratory understood exactly why they were right. If this is your first time here, welcome. This channel exists for stories exactly like this one, the places on Earth where geology, deep history, and the oldest surviving human memories collide. We go looking for sites that were feared long before they were ever formally studied, and we take the underlying science seriously enough to ask why that fear existed in the first place. Today, that means a scarred crater field in the middle of the Australian outback that took the scientific world more than 3 decades just to properly identify, and another 5 decades after that to stop quietly, carelessly destroying. If that's the kind of investigation you want more of, the subscribe button is right there, and the bell icon next to it means you won't miss what we dig up next. Now, back to the beginning. Back to the ground itself, and to what actually made it. To understand why this place unsettled the people who've lived near it for thousands of years, you first have to stand on it. Roughly 145 kilometres southwest of Alice Springs, where the sealed certainty of the Stuart Highway gives way to the red dirt washboard of the Ernest Giles Road, the land does something it does nowhere else on the continent. Central Australia, for hundreds of kilometres in every direction, is otherwise unremarkable, in the particular way so much of the outback is unremarkable. Gravel plains, low mulga scrub, spinifex tussocks, a horizon so flat and so wide it plays tricks on the eye by mid-afternoon. Heat rises here in visible sheets for most of the year, bending the line where red earth meets pale sky until the distant scrub seems to float above the ground. Even the silence has a texture to it, the kind of stillness that makes the occasional call of a crow or the tick of cooling stone at dusk feel unusually loud. And then, without warning, the earth is broken open. Not one crater, 14 of them, scattered not in a neat line but strung out in a long, deliberate-looking ellipse across less than a square kilometre and a half of desert, as if something had opened fire on the landscape from directly overhead and walked its shots across the ground. The smallest depression is barely 7 metres across, easy to walk straight past if you don't already know to look for it. The largest is an entirely different matter, close to 180 metres wide and as much as 15 metres deep, a bowl so large that a visitor standing at one rim can lose sight of a person standing at the opposite edge in the heat shimmer rising off the rock. For more than 3 decades after Europeans first laid eyes on these craters, nobody agreed on what had made them. They didn't look volcanic. They didn't look eroded. And yet at least one early visitor, staring down into that improbably perfect bowl back in 1899, couldn't shake the sense that human hands had to be involved. Because what else, at the turn of the 20th century, carved holes like that into solid rock? The real answer, once it finally arrived, was almost too strange to feel like relief. What struck this stretch of desert wasn't a single object. It was many, the shattered remains of one iron meteorite, weighing several tons as it entered Earth's atmosphere, already fractured deep inside by shear planes and internal cracks likely inherited from some earlier, violent collision out in space. As it screamed downward at somewhere close to 40,000 kilometres an hour, the sheer pressure of the atmosphere finally tore the weakened mass apart. It never hit the ground as a single body. It hit as a swarm, the 4 largest fragments, each roughly the size of a 200-litre fuel drum, gouging out the major craters that dominate the site today, while as many as 8 smaller pieces fell short and carved out the shallower depressions to the southwest. Geologists classify what remains of that meteorite as an octahedrite, a common but ancient variety of iron meteorite, composed of roughly 90% iron and 8% nickel, crystallised into the octahedral lattice pattern that only forms when molten metal cools with almost unimaginable slowness over millions of years deep inside the core of a shattered planetary body, long before our own solar system had finished taking shape. Chemically, researchers place the Henbury iron in what's known as the EARB classification group, a signature specific enough to let scientists rule out any connection to Australia's other 2 famous impact sites. Wolf Creek in the far northwest and Box Hole not far away, proof that, despite their surface similarities, all 3 represent completely separate falls from completely separate objects. The impact left its own signature written into the surrounding rock. Fragments recovered from the site show clear evidence of having been superheated to somewhere near 850 degrees Celsius, hot enough to partially melt the silica in nearby stone into glass. Hot enough to suggest that at least one fragment didn't merely strike the ground but detonated on contact, throwing a curtain of molten rock and vaporized metal outward across the desert floor. Around 2 of the 14 craters in particular, researchers found something rarer still, radiating rays of ejected material fanning outward from the rims. Structurally similar to the bright ray systems photographed around fresh, young craters on the surface of the Moon, it remains one of the only places on Earth where this kind of feature has ever been documented on a terrestrial impact site at all. As for timing, scientists now place the impact at roughly 700 years ago, calculated from the cosmogenic radiocarbon signature preserved inside the meteorite fragments themselves. For decades before that refinement, an older method using fission tracks in the surrounding glass could only narrow the event down to somewhere between roughly 2300 and 6100 years ago, a margin of error wide enough to swallow the entire span of ancient Egyptian civilization inside it. Today, the site sits inside the Henbury Meteorites Conservation Reserve, 16 quiet hectares administered by the Northern Territory Government, with a self-guided walking trail looping visitors past the rims of the largest craters. On a calm afternoon, with the light going gold and the spinifex barely moving, it looks almost peaceful. The scientific attention paid to this narrow stretch of desert has never really stopped. In 1965, researchers produced a detailed structural map of one crater alone, tracing the exact distribution of its ejecta rays loop by loop, a level of documentation rare for any impact site this size anywhere on the planet. A more comprehensive study followed in 1972, examining the mechanics of the whole crater field in far greater depth, and researchers have continued returning to Henbury in the decades since, re-examining old evidence with new instruments and revisiting questions the original 1930s fieldwork simply didn't have the tools to answer. Few small crater fields anywhere in the world have been studied this continuously, for this long, by this many independent teams. None of that ongoing science makes the place any less remote. Getting to Henbury today still means leaving the sealed highway behind, following an unsealed road that can close entirely after heavy rain, and arriving prepared to bring your own water and firewood if you intend to camp. It is not a place that welcomes the unprepared, even now. Even with a marked trail underfoot, it did not look peaceful on the day it was made. Long before any European surveyor stood at the rim of these craters and scratched his head, the people of this country already knew exactly what this place was. The Henbury crater field sits at a genuine crossroads, both geographically and culturally. It lies on country where the traditional lands of 4 separate Aboriginal language groups meet: the Arrernte, the Luritja, the Pitjantjatjara, and the Yankunytjatjara. In the Arrernte language, the Northern Territory's own Parks and Wildlife Commission records the site under the name Tatjaya, sometimes rendered Tatjakapara. It's worth sitting with that fact for a moment. This was never an unnamed, unknown stretch of desert that European settlers stumbled onto and had to make sense of from nothing. It already had a name. It had always had a name. That crossroads position is not a small detail. In the deserts of Central Australia, language boundaries were never arbitrary lines on a map. They marked the edges of deep. Specific relationships between people and country, maintained and renewed over an immense span of time. A site significant enough to be known, named and actively avoided across 4 neighbouring language groups at once, was a site whose danger, whatever the people who lived here understood it to be, was taken with real, shared seriousness. It's important to say clearly, and with genuine respect, that not everything known about this site by its traditional custodians has ever been made public, and not everything should be. The Northern Territory's own park authorities are explicit that some of the deeper cultural knowledge tied to Henbury remains reserved, to be shared only with the consent of the Aboriginal custodians who hold it. Everything that follows here draws only from what has already been recorded and published over decades by researchers and anthropologists working directly with community members who chose to share it. Even that fragment, on its own, is extraordinary. Among the Luritja, whose country borders the crater field, the account recorded from elders describes a fire devil that ran down out of the sun and made its home in the ground at this exact spot. It was said to burn and consume anyone careless enough to disturb it. Camping near the craters was forbidden. So was drinking any water that pooled inside them after rain. Not because the water looked unusual, but because of what the old law said it carried. The fire devil, it was believed, would fill anyone who drank it with iron. Sit with that claim for a second, stripped of its supernatural framing. A fire came down from the direction of the sun. It made a home in the ground, and the water collecting inside its home carries iron. That is, in plain scientific language, a startlingly precise description of an iron meteorite strike. A second story is tied specifically to the largest of the 14 craters, the near-perfect 180-metre bowl that dominates the site, in accounts recorded by the Australian anthropologist and photographer Charles Mountford, who spent decades documenting Aboriginal knowledge across the continent. The crater's shape is credited to an ancestral being, a giant lizard woman named Mulamura, who dug down into the earth at this spot and hurled the excavated soil outward as she went. forming both the deep bowl of the crater and the long radiating streaks of reddish, iron-flecked earth fanning out from its rim. To a modern geologist, those radiating streaks are the ejecta rays, the same rare moon-like feature researchers still study today. To the story, they are the marks left behind by a digging god. Both accounts are doing the same essential work. Both are explaining, in the only language available to a culture without seismographs or spectrometers, something that genuinely happened. A violent, burning object came out of the sky, reshaped the ground on impact, and scattered iron across the earth in patterns radiating outward from a single point of origin. The clearest sign that this was never casual folklore came in 1931, when a party of outside scientists finally travelled to Henbury to investigate the craters firsthand. They brought an Aboriginal guide with them. As the group drew close to the crater field, the guide simply stopped walking. He would go no further, and he told the scientists plainly why. This ground was forbidden to his people, the exact spot where a being of fire had dropped down from the sun and consumed the land in flame, tearing open these wounds in the earth. No argument from the visiting party could talk him past that line. He held it, and in the end they respected it. It would be easy, and it would be lazy, to file that moment away as old superstition quietly stepping aside for new science. Decades later, researchers studying the story in detail would argue that almost the exact opposite was true. When cultural astronomer Duane Hamacher of the University of New South Wales examined the Henbury oral tradition closely, he found a level of descriptive precision that was difficult to write off as coincidence. Fire from the direction of the sun, a violent home made in the earth, danger specifically tied to the craters and to the water pooling inside them. His conclusion was that this wasn't a story that had drifted loosely across generations the way rumours typically do, gathering embellishment as they travel. It behaved instead like a maintained record of a real event, potentially carried forward across more than 200 generations, a span stretching back close to the full 700-year age of the impact itself. 200 generations. Long before Rome existed. Long before the pyramids of Egypt were built. Long before writing existed in almost any form, anywhere on earth, someone standing on this ground watched fire fall out of the sun, watched it bury itself violently in the earth, and made absolutely certain that their children, and their children's children, would never forget to stay away. They were not wrong to warn them. With the full shape of what this place actually is now in view, it's worth tracing exactly how the outside world came to understand it, because that story has its own share of strange turns, false starts, and quiet losses. 1899, the first written record. The earliest European account of the craters comes from a station owner named Walter Parkey, who described the site in a letter to the anthropologist Frank Gillen. Parkey didn't reach for a scientific explanation, because he didn't have one available to him. He reached instead for the only frame of reference that made sense, telling Gillen that in all his years in the country, he had never come across anything as strange as this, and that if pressed to guess, he'd have said human hands must have carved it, except he couldn't begin to imagine when, by whom, or for what possible reason. For more than 3 decades after that letter, the question simply sat there, unresolved, while the craters waited in the desert. Around 1916, a prospector connects the dots. A prospector named Jay. Max Mitchell was the man who finally began closing the gap between the strange holes in the ground and their true cause. Passing through the region, Mitchell came across a heavy, unusually dense fragment of iron being kept at the Henbury cattle station, the kind of object that, to a man who spent his working life reading the ground for valuable minerals, immediately felt wrong for an ordinary stone. He suspected he was looking at meteoritic material, and that the nearby craters might well be connected to it. It would take him years to find anyone with a laboratory willing to take the idea seriously. 1930 to 1931, a meteorite falls elsewhere, and Henbury finally gets its hearing. The breakthrough arrived almost by accident. In 1930, a genuine meteorite fall was witnessed streaking across the sky over Karoonda in South Australia, a dramatic, unmistakable event that put meteorites back into public and scientific conversation across the entire country. In the excitement that followed, Mitchell's old suspicion about Henbury suddenly had an audience willing to listen. He sent a fragment to Professor Kerr Grant at the University of Adelaide in 1931, and geologist A.R. Alderman travelled to the site to investigate in person, publishing his findings the following year. For the first time, in ink in a scientific journal, Henbury was formally confirmed. Not sinkholes, not ancient quarries, not anything dug by human hands, but the unmistakable scars of a meteorite strike, the first site in Australia ever officially proven to be one. 1931 to 1938, the plundering begins. Word of the discovery didn't only attract scientists, it attracted collectors, and one collector in particular reshaped the fate of the site more than almost anyone else in its history. Robert Bedford, an amateur naturalist who had founded a small private museum in the South Australian town of Yankunytjatjara 2 years earlier, arrived at Henbury within weeks of Alderman's own visit. On that first trip alone, in June of 1931, Bedford and his companions collected 550 individual pieces of meteoritic iron from the crater field. The vast majority of it, 542 pieces, weighing in at 146 kilograms, he shipped directly to the British Museum of Natural History in London. He didn't stop there. Bedford returned to Henbury again and again over the next 7 years, pulling more material out with every visit. Even Bedford's own collection didn't stay together for long. The small Yankunytjatjara museum he had founded to house it was itself broken up decades later in 1972, its holdings sold off and dispersed to institutions around the country. Museums Victoria alone would go on to acquire roughly 24 pieces from that dispersal, a small fraction of a single private collection that had, in turn, been carved out of a small fraction of the original meteorite. Piece by piece, sale by sale, the story of Henbury became a story of dispersal, one that scattered the physical evidence further with almost every decade that passed. By the time this first wave of organised collecting had run its course, more than 1/2 ton of meteoritic material had been physically removed from the site, carried off in crates to collections in London, Adelaide, and eventually as far away as the Smithsonian in Washington, D.C. Some of it has never returned. And formally trained scientists weren't the only ones digging. Amateur fossickers and curious travellers followed for decades afterward, almost entirely unsupervised, working over a site with no formal protection and nobody stationed there to stop them. The cost of all that unregulated attention wasn't only measured in kilograms of iron carried away. It was measured in something that, once lost, could never be recovered. The delicate ejecta rays radiating outward from 2 of the craters, the same rare moon crater-like feature that had made Henbury scientifically extraordinary in the first place, were gradually scuffed away, disturbed, and erased by decades of feet and shovels moving across ground nobody was watching. Researchers studying the site today can only reconstruct what those rays originally looked like from photographs and field notes taken in the earliest years, because the physical evidence itself no longer survives in anything close to its original state. It would take until 1964 for the site to be formally set aside as a conservation reserve at all, and even then, the fuller protective status that finally treated the crater field as the irreplaceable scientific and cultural site it actually is, didn't arrive until 1980. Do the arithmetic, and the gap lands almost exactly where the title of this video says it does. Very close to 50 years between the moment the outside world officially learned what Henbury truly was, and the moment it was finally treated like something worth protecting. So if you came here expecting this to end with aliens, or with some unexplained force still lingering inside those craters today, I understand the temptation, but stay with me, because what actually happened at Henbury over the following decades of research is genuinely stranger than that. Scientists didn't just confirm that a meteorite struck the ground here. They ended up asking a far bigger question. How does a piece of human memory survive? Intact and accurate, across 200 generations, inside a culture with no written language at all? The answer researchers eventually arrived at says less about ancient superstition than it does about how seriously we should be taking oral history everywhere on this planet. If you want to see exactly where that investigation went, make sure you're subscribed, because it only gets stranger from here. Once scientists accepted that Henbury really was the site of a meteorite strike, the investigation didn't stop there. If anything, that confirmation opened up a longer, more careful line of questioning that would take decades to properly work through. The first job was ruling out the alternatives. Before 1931, plenty of outside observers, Walter Park among them, staring baffled into that first crater back in 1899, genuinely wondered whether human hands had dug these holes. Others floated the idea that they might be old volcanic vents, or some unusual erosion feature specific to the local sandstone and shale. Alderman's original fieldwork worked systematically through each possibility and eliminated them one by one. No lava, no volcanic ash, no plausible excavation method that lined up with holes of this size, this shape, and this apparent age. What he did find, chemically distinct iron fragments, heat-fused glass, a debris pattern radiating outward exactly the way you'd expect from a high-speed impact rather than a slow, deliberate dig, left very little room for doubt. Later researchers went further still, running detailed chemical analysis on the recovered iron, and comparing it directly against meteorites found at Australia's other two well-known crater sites, Wolf Creek and Box Hole. The results confirmed Henbury's meteorite was chemically distinct from both. 3 separate falls, 3 separate events, not one shared object scattered across the continent. That geological case has only grown stronger with time. Researchers have returned to re-examine the Henbury evidence repeatedly since Alderman's original fieldwork, most substantially in a major re-evaluation that gathered previously unpublished field documents, expanded the data on how meteoritic material is distributed across the site, and tested the original impact models against a far more modern understanding of how objects actually behave at these speeds. None of that renewed scrutiny has ever turned up anything to support a non-impact explanation. If anything, each fresh look has tied the physical evidence more tightly to the same conclusion Alderman reached in the 1930s, just with better instruments and a great deal more data behind it. That accounts for the geology. But any site that looks like this, a cluster of violent scars in one of the most remote deserts on Earth, tied to warnings from an ancient culture about a supernatural being of fire, is exactly the kind of place that tends to accumulate a second. Much newer layer of mythology once word spreads beyond the scientific literature. Isolated craters and unusual landforms around the world have long attracted precisely this kind of speculation. Claims of lingering magnetic disturbances, theories about buried technology, the reflexive instinct to lump any remote, strange-looking landscape in with something like the Bermuda Triangle. Henbury, sitting in one of the most sparsely populated stretches of the entire country, has not been immune to that same impulse in the more casual corners of the internet. None of it survives contact with an actual instrument. Iron-nickel meteorite fragments are naturally magnetic on a small, local scale, are genuinely useful. Low-tech method researchers still use to locate buried fragments in the surrounding sand today. But there is no large-scale magnetic anomaly at Henbury capable of affecting a compass, a phone, or a human body from any meaningful distance. There's no unusual radiation on record. No unexplained technology has ever turned up across any of the numerous expeditions, or scientific surveys carried out at the site since 1931. Every mysterious flourish attached to Henbury in the pop mythology sense tends to evaporate the moment somebody actually brings real equipment out to it. What doesn't evaporate is the oral tradition, and this is where the real investigation gets genuinely interesting. Because the question researchers like Duane Hamacher eventually asked wasn't, is the fire devil story true or false? It was a sharper, more testable question. Does the level of detail in this specific account line up with what we independently know about the physical event, closely enough that coincidence becomes difficult to believe? Line the pieces up. Fire, arriving from the direction of the sun. An impact violent enough to be described as that fire making its home in the earth. A fair, plain language description of an object burying itself below the surface. A specific warning against drinking pooled water inside the craters, tied to the belief that it would fill a person with iron, which happens to be exactly the kind of trace contamination you'd expect from standing water sitting inside a crater lined with fragmented iron-nickel meteorite. These aren't the kind of details an unrelated legend, invented for some entirely different purpose, would be likely to get right purely by chance. That's the case Hamacher and his colleagues have made in the academic literature, that this isn't folklore drifting loosely across time the way a fable does, gathering random embellishment as it travels. It behaves like a maintained record, a specific set of facts, protected and deliberately repeated across an extraordinary span of time, precisely because the people carrying it understood exactly how dangerous the truth actually was. Not every scholar of oral tradition agrees on precisely how much technical detail can survive fully intact across 200 generations without distortion. That remains a genuinely open, actively debated question in the field. But even researchers who stay cautious about the exact number of generations involved tend to agree on the harder part to dismiss: the correspondence between this specific account and this specific stretch of scarred desert is too precise to write off as coincidence. Something real happened here, and somebody made absolutely certain it would never be forgotten. So what is the grounded, unglamorous truth behind Henbury? It isn't a curse. It isn't some force still lingering in the ground. It's something both simpler and, in its own way, far more unsettling. This place is exactly as dangerous as it looks, for reasons that are entirely physical, entirely explicable, and entirely capable of killing anyone unlucky enough to be standing here on the day it happened. Picture it the way a geologist would reconstruct it. A mass of iron weighing several tons, already fractured deep inside from some ancient collision far out in space, comes screaming into Earth's atmosphere at somewhere close to 40,000 kilometres an hour. The friction and pressure of the atmosphere itself tear the weakened structure apart in mid-air, low enough that the fragments are still travelling at devastating speed by the time they reach the ground. Multiple impacts, mere seconds apart, each releasing energy on a scale modern witnesses have only experienced a handful of times in recorded history. Events like the Chelyabinsk airburst over Russia in 2013, or the Tunguska event of 1908, both of which flattened landscapes and injured people from shockwave and heat alone, with nothing supernatural required to explain any of the damage. At Henbury, at least one fragment appears to have detonated directly on impact with enough force to fuse the surrounding rock into glass, meaning temperatures at the point of contact briefly exceeded 850 degrees Celsius. Anyone standing within range of that event would have experienced a wall of heat, a deafening shockwave, and a rain of molten superheated debris, all within a matter of seconds, with little warning beforehand beyond, perhaps, a light in the sky. That is not folklore. That is orbital mechanics and thermodynamics. And it is precisely what the old warning describes, stripped of nothing but its language: fire, falling from the direction of the sun, making a violent home in the earth, capable of burning anyone unlucky enough to be caught in its path. The old law was not exaggerating for effect. If anything, Fire devil may be a remarkably restrained way to describe what actually tore across this stretch of desert almost 5,000 years ago. There's a plainer, more immediate version of danger here too, one that has nothing to do with meteorites at all. This corner of the Northern Territory remains one of the more remote and unforgiving environments on the continent. Summer temperatures routinely climb past 40 degrees Celsius. The nearest serious medical help is well over an hour away, even in good conditions, and the unsealed road in can close entirely after rain, cutting the reserve off. None of that requires a fire devil to explain it. It's simply what this landscape has always demanded of the people who move through it. Ancient and modern alike, respect, preparation, and the humility to know that indifference to a place like this can be every bit as dangerous as anything that fell out of the sky. But there's a second, quieter danger this story reveals, one with no ancient precedent at all, because it's a danger the 20th century invented entirely on its own. For nearly 50 years after science confirmed exactly what Henbury was and exactly how significant it was, no one with real authority stepped in to protect it. A private collector could simply arrive, load hundreds of kilograms of irreplaceable material into crates, and ship it to the other side of the world, again and again, for years, with nobody positioned to stop him. Multiply that single collector's haul across every visitor who followed his example over the next 3 decades, official and unofficial alike, and the arithmetic becomes sobering. Of the several tons this meteorite is estimated to have weighed when it entered the atmosphere, only a few hundred kilograms have ever been recovered and catalogued at all. Most of it long since dispersed into collections scattered across 3 continents. Tourists and amateur fossickers could walk the fragile ray-marked ground around the largest craters unsupervised for decades, slowly scuffing away geological evidence that had survived intact since the Bronze Age, simply because no one in a position of authority treated the site as something worth guarding. By the time real protection finally arrived, some of the rarest physical evidence this planet has to offer, those moon-like ejecta rays, visible almost nowhere else on Earth, existed only in old black and white photographs and the handwritten field notes of the small number of scientists who saw them before they were gone for good. That is the truth that took 50 years to fully reckon with. Not a monster, not a mystery beyond explanation, a slow, entirely preventable act of erosion, carried out not by wind or rain, but by human hands that never once stopped to ask permission from the ground they were standing on. The Aboriginal custodians of this land never made that mistake. Their law told them plainly, don't camp here, don't drink here, don't take from this place. It was a warning dressed as prohibition, built to survive being repeated by people with no other way to record it. Modern conservation law eventually arrived at almost exactly the same conclusion. Leave it undisturbed, protect what remains, don't take what isn't yours to take. It just took the rest of the world nearly 5,000 years, and one very expensive, very avoidable round of plundering to catch up. Standing at the rim of the Henbury craters today, it's hard not to feel the strange doubled weight of the place. Beneath your feet is a 5,000-year-old wound, left by something that struck with more violence than almost anything a human being has ever directly witnessed and survived to describe. Layered on top of that geological record is a second, far more recent story, of a truth that took the outside world 3 decades to even recognise, and another 5 decades after that to finally start treating with the seriousness it always deserved. What makes Henbury remarkable isn't that it's mysterious, it's that, eventually, it stopped being mysterious at all. Every thread of it, the shape of the craters, the chemistry of the iron, the heat-fused glass, even the specific warning about the water ties back to one violent afternoon in the deep past and to a culture that watched it happen and made absolutely certain the memory would outlive them by thousands of years. Science didn't have to invent an explanation here. It only had to finally start listening to one that had already been offered. patiently, for 200 generations. It also means the ordinary human failures that very nearly erased this place, the greed of individual collectors, the decades of institutional carelessness, the better part of 50 years spent simply looking the other way, were never inevitable. They were choices, made again and again by people who could have chosen differently and who were eventually required to, once the law finally caught up with what the land had been saying all along. That's really the heart of every story this channel tells. The line between an ancient warning and a modern scientific finding is almost always thinner than we assume. Sometimes the old stories aren't guesswork. Sometimes they're the only surviving instrument that happened to be there when it actually mattered. What do you think? Should evidence like this change how seriously we take other ancient warnings and oral traditions around the world? Let me know in the comments below. And if you want to keep exploring the places where geology and deep human memory collide, subscribe, and I'll see you in the next one.